Everything you're about to see looks fake. But every experiment in this video is 100% real physics. Some physics experiments are so strange that they look like CGI or visual effects. But what you're seeing here isn't editing, tricks, or animation. These are real experiments that show how weird the real world actually is. Let's start with the first one. Picture this, an object that rolls uphill, seemingly defying gravity. It sounds impossible, right? This is the double cone illusion. When you place a specially shaped double cone at the bottom of a V-shaped ramp, it starts to roll upwards, towards the wider end. It looks like it's breaking the most fundamental rule of physics. But it's not. The trick lies in the object's center of mass. Even though the cone appears to be moving up the ramp, its center of mass is actually moving down. The V-shape of the ramp gets wider, and as the cone rolls uphill, the points where it touches the ramp are actually lower than where it started. So gravity is still doing its job, pulling the cone's center of mass downwards. It's a brilliant example of how our eyes can be fooled by clever geometry. This isn't impossible motion. It's just a really cool gravity experiment that plays with our perception. It shows that what we see isn't always the full story. Next up, we have something that looks like it came straight out of a sci-fi movie. It's a rope that seems to be frozen in place, moving in beautiful, elegant patterns. These are called standing waves. When you take a rope, fix one end, and vibrate the other at just the right frequency, something magical happens. The waves traveling down the rope interfere with the waves reflecting back. At specific frequencies, called resonant frequencies, they combine perfectly to create these stationary patterns. It looks like a physics wave illusion, but it's a very real phenomenon. The parts of the rope that are completely still are called nodes, and the parts with the biggest swings are called antinodes. By changing the frequency of the vibration, you can create different numbers of these loops. This simple vibrating rope experiment is a powerful way to visualize how waves, from sound to light, actually work. It's a fundamental concept in wave physics, made visible and almost hypnotic. Now, let's play with a substance that looks like a living, breathing creature from another planet. This is ferrofluid. It's a liquid filled with tiny magnetic particles, so small they're nanometers in size. On its own, it just looks like a dark, oily puddle. But bring a magnet near it, and the ferrofluid comes alive. It sprouts spikes and morphs into incredible, intricate patterns, perfectly tracing the invisible magnetic field lines around the magnet. This isn't a liquid metal illusion from a movie. It's a real-time visualization of one of nature's fundamental forces. As you move the magnet, the ferrofluid follows, creating these mesmerizing, spiky sculptures. This ferrofluid experiment is not just for amazing science visuals. It has real-world applications in things like loudspeakers, hard drives, and even medical treatments. It's a stunning display of magnetism physics, showing us the hidden architecture of magnetic fields in a way that's both beautiful and a little bit spooky. Have you ever spun a coin and watched it wobble faster and faster right before it falls? Euler's disk takes that simple act and turns it into an incredible demonstration of physics. Euler's disk is a heavy, thick, polished disk designed to spin for a very long time on a smooth, slightly concave surface. As it spins, it also wobbles or precesses. What's amazing is how the sound changes. The frequency of the spinning and the sound it makes increases dramatically as it loses energy, ending in a sudden, high-pitched whir before it comes to an abrupt stop. It looks and sounds like it's speeding up, which seems to defy the conservation of energy. But this is a physics sound illusion. The disk is actually losing energy the whole time due to friction and air resistance. The increasing frequency is a result of its rotational motion and the complex interplay of angular momentum and gravity. This spinning disk experiment is a captivating look at how energy is dissipated in a rotating system. It's a simple concept with a surprisingly complex and fascinating outcome. For our final experiment, we're going to see the incredible power of something we can't even see, air. This is the vacuum cannon. It's a simple setup, a long pipe sealed at both ends with a ping pong ball inside. The trick is to suck all the air out of the pipe, creating a vacuum. Now, the outside air is pushing on the ends of the pipe with immense force, about 15 pounds per square inch. When you break the seal on one end, that air pressure rushes in to fill the vacuum. It acts like a powerful explosive, launching the lightweight ping pong ball out the other end at supersonic speeds. This isn't just a simple air pressure experiment. It's a demonstration of a massive physics force. The ball can travel so fast it can punch through aluminum cans or shatter wooden boards. It looks like a powerful explosion, but it's all driven by the pressure of the air around us. This explosive science experiment is a dramatic and unforgettable real physics demo of how powerful a simple pressure difference can be. If these experiments surprised you, there are many more that look fake but are completely real. Subscribe if you want to see more real science that doesn't look real at all. Thanks for watching.